Redistribution using prefix lists. I was going to jump straight into the config of this one, but I definitely think we can use some explanation of prefix lists first. Well, let's start off with the question, what are prefix lists? Essentially, they are an alternative for an access list in terms of matching routes, and typically used with route filtering. You see them used all the time with BGP for identifying routes that you want to set some special attribute for. Think about ACLs, access control lists. They're pretty universal. You use them for VPNs, for security, for filtering Telnet and SSH, for quality of service, for, I mean, the list goes on and on and on and on and on. They do everything, right? Prefix lists have one use, and that is matching routes. They're not universal like ACLs. They're easier on your router's processor and give you a little more flexible subnet mask matching abilities. Essentially, you say, I want to match the 172.16.1.0/24 subnet. That's an example of a prefix list, right? You say permit, just like an access list, permit this. And that would be a way of just quickly matching it. So similar structure to ACLs. You got the permit and deny, you got the implicit deny at the end, etc., etc. But it uses a two-stage matching system. It's going to match the network and the mask. And I'm actually going to describe that in the next slide. It will make a lot more sense there because this will hurt your brain. This is, when you first see this, you're going to be like, what? Once you get it, you're going to feel pretty cool. They're kind of like subnet masks that way. Once you get subnet masking, you're like, I'm awesome. So here's an example. Best way to get these is just to see examples of them. You go into global config mode, type in IP prefix list, you name it. In this case, I put JC, permit, and then what do you want to filter? 172.30.0/16. It uses CIDR notation. So what does that actually permit or match in this? And keep in mind how you apply this. This is like an access list. You can create these all day. Until you apply them, they don't do anything. So what does this actually match? This guy. 172.30.0/16. Even though this, and this are derivatives or subnets, I should say, of 172.30.0, they do not match. This is a very specific match of a prefix list. All right, let's add a little more to it. Same statement, permit 172.30.0/16, but now we've added on LE20. What's that? LE stands for less than or equal to 20 is bits. Bits of what? Subnet mask. So essentially, this now, when you do this, becomes a two-stage matching system. Match number one is saying, okay, I'm going to permit 172.30.0/16, right? Essentially, that's does it fall under that category is the way I would say that now. Match number one. And then I would continue that and say where the subnet mask is less than or equal to 20 bits in length. Okay? One of the only ways to get this is by looking at the example. Okay, how about this guy? Does it match? 172.30.10/24. Well, it passes check number one, meaning it's a subnet of 172.30.0. Now I know some of you are like, whoa, wait a sec, Jeremy. Last slide you said that didn't match. Well, that's because last slide we didn't have this. When you add that little LE, or another one will be GE, to the end of it, it changes the story. So essentially, match number one says, yes, this is a subnet of 172.30.0. Next question says, okay, then is it subnet mask less than or equal to 20 bits? Nope, it is not. So that does not match. How about this guy? 172.30.0/16. Does that match? Bing, it does. Why? Because it matches this. It's a 172.30.0/16, right? Matter of fact, it's exactly that. And its subnet mask /16 is less than or equal to 20 bits in length. Okay, how about this guy? 172.30.32.0/19. Okay, let's ask the question. Is it a subnet of 172.30.0? Yes, it is. Is it subnet mask less than or equal to 20 bits? Yes, it is. Bing. It matches. That one would be permitted by that statement. You seeing how this works? It's weird at first. Get used to it. Down below, does this one match? Well, I can say right away no, because it doesn't pass the first match check. It says I'm 172.16. Doesn't even compare the subnet mask, even though the subnet mask would have passed that. It didn't pass check number one. How about this? 172.30.10. Nope. Same reason for A. So those last two miss the specificity of the subnet mask check. Okay, feeling a little warmer and fuzzier maybe? Okay, let's look at another example. Same thing again, same subnet, but now we've changed the story to say GE. That's greater than or equal to 20. And by the way, if you're ever bored on Friday night, you can combine these. You can put LE, you would squeeze in here, you can put LE maybe 19 and GE 20. Now, Don't worry, I'm going to give you some practical, like you're like, where would I use this? I'll tell you in a second. So GE stands for greater than or equal to, let's look at it. 172.30.10/24. Does it match? Okay, check number one, 172.30. Yes, it's a derivative of that. Check number two, is it subnet mask greater than or equal to a 20? Yes. Bing. It is. I don't know why I got this Bing thing. It's not a search engine, it's a word. So /24, it does match that. It is greater than or equal to 20. Now, okay. Hang with me here. Look at this one. 172.30.00/16. It is the subnet. Of course it matches, but why? It does not pass this permit statement because its subnet mask is not greater than or equal to 20. It always, that's why I say the biggest thing you can do is always think of this as a two-check system. It did not meet the specificity requirements. How about this guy? 172.30. So essentially, we reverse the story from the last slide, right? This guy is, again, not specific. How about this guy? 172.16, double errant. Nope, doesn't match this or this. Last one, bing. It does match. 172.30.10.0 is a subnet of the /16 and has a specific subnet mask greater than or equal to 20 bits. Now you might be wondering, where on earth would I use something like this? Well, I will say prefix lists are used all the time with BGP. Why? Because think of it this way. As a service provider, you are an ISP, right? Or a major service provider. You will have all kinds of customers. So let's just say you end up with a public subnet, 150.15.0.0/16, a real public address, and then you start dividing that up with your customers. Well, a lot of your customers will want to run BGP because they might have connections to other ISPs, competitors, but essentially gives them redundancy. So you might take subnets of this and say, okay, well, I want to make sure that I carve out pieces of this for you so that you can use, I'll give you, customer X, 150.15.1.0/24, so you can use that on your network. And they'll use BGP with you as not only a keep alive mechanism to make sure the connection is good and alive, but they can also use BGP to advertise that prefix or that subnet out the other ISP. So if you entirely goes down or they entirely goes down, they still have redundancy. The rest of the world can essentially take the alternate route in to reach that same subnet. That's done all the time. It's the reason you do BGP in the first place as a customer. Now, what's the risk? Well, with BGP, that customer might subnet that themselves. They may, matter of fact, I've actually run an organization like this to where we would take this and we would be a service router for a bunch of little customers. Like we would have AT&T, we'll say, as a customer, and I would have a rack in a data center. And I would get a /24, and I would break that up for all of my customers who would run their own little networks. And long story, I could get into that. But essentially, I would then have all these little subnets of that /24. This guy might get a /30 for his WAN link. He gets a /30. And if I do BGP wrong, I might advertise a whole bunch of little subnets back up. Well, the problem is with an ISP, you get enough customers doing that, and your routers are tanked, because your routing table is massive with all these tiny little subnets. So you can write in the contract, say, we are going to run BGP with you. We're happy to do this because you're paying us a tremendous monthly fee. But we're going to apply a prefix list to say you cannot give us or advertise subnets more specific than a we'll just say /25. That's as specific as you can get. If you do anything greater than that, it's going to be denied. So you would use, in this case, an LE25. I'm going to permit subnets that are less than or equal to 25, giving them some flexibility, or maybe use a 26 or whatever the case you may be. Essentially, you as the service provider are protecting your routing table from being flooded by all these little subnets. And I guarantee you, AT&T, they've got connection to Time Warner, Level 3, all these different carriers that are out there, Sprint, and they all the time will put prefix lists and say, AT&T, you cannot advertise, you've got to summarize, because again, millions and millions of routes in the internet. Our goal is to try and summarize and keep them as efficient as possible to keep our internet routers fast. That's where you see prefix lists all the time. Just so we have the time available to us, I want to call this nugget prefix list concepts. I'm going to break the configuration to a separate nugget where we can spend the time going through and applying this using route maps. I hope this has been informative for you, and I'd like to thank you for viewing.